Okay, this is going to be part two. We're going to do the electronics, wire them in, and the first thing we're going to do is a big no-no. We're going to take it apart with the power on. If I let the smoke out, guess what? I'll share that with you too, because that's what's likely to happen doing this. But I want to diagnose the electronics as I take it apart, so that's why I'm doing it with the power on. Okay, so 2mm Allen heads. Pull this plate off. We already pulled the knob off. You're going to notice I use a lot of hand tools. It's not that I don't have the power tools. I do. It's just that power tools strip threads. Power tools round out Allen heads. They don't allow you to hand fit things. They're just for jamming stuff together or apart. And generally, they do more harm than good. If you can do it with your hand tools, you're doing a better job. It's a requirement. A lot of the motors I used to build long ago, it was really funny watching the guys. They'd strip the gaskets off a Mercedes block, $30,000 motor. They pull out the air gasket removing tool and strip the gaskets off the block, aluminum block. And then when the job's done, the car comes in, it's leaking water out from underneath the heads. I guess we'll remove this pot. We're obviously not going to use it. Why don't we get that wiring out of the way, out of the backside too. The pot goes to right here, backstabbed into these two spades and that one, which means obviously this is the motor control board. And this is going to be down here. This is going to be the digital display speed control board, probably, that hooks up to the LED or the digital readout in the front. So we're going to try to remove this board right here with the pot and energize just this board down here. We're also going to energize the safety for the chuck key so that the lid has to be down to turn it on, and we're going to link that. We're going to wire that in differently because it doesn't allow us to power up the digital out front. We want the digital on all the time regardless if the door's open or closed. We only want this to shut down the new unit when the key is open, when the lid is open, so the key doesn't get thrown at me, especially at 3,500 RPMs instantly. So this digital readout board, apparently, the red here is actually neutral. It goes to ground via the magnetic switch. The black is hot, 120 volts. Also goes to the magnetic switch. We're going to need to use those. They're direct. They obviously bypass the motor control board. This yellow wire goes up to the rotary speed forward reverse switch. This yellow wire goes to the motor control board. I imagine we can eliminate these two yellow wires completely. This red wire right here goes up to the magnetic switch. It's probably a power supply for the motor control board. This red wire right here and this black wire right beside it right here go down to the digital display board, motor speed display board. The question is, do these two wires right here feed this board from here, or does this board feed this? Looking at the transformers on this board, I would say this board actually feeds the motor control board rather than the other way around. We're going to pull those two wires off first and see what happens. Okay, with those two wires pulled, obviously the power is going from the speed digital display to the motor control unit because the motor control unit is unplugged now and the digital display is still working. We're going to pull the rest of it out. I guess we may as well pull the reversing switch out. Not going to use it initially. There is a way to wire it in. I may do it eventually, but I'm not going to do it this install, at least not yet. Knob comes off straight. Something moved. Oh, wait a minute. We got this little piece right here. Aha! There's your answer. So I tell the guy with the Mercedes that I'm going to have to pull the head off, probably replace the head gasket. And he looks at me a little stunned. He says, $6,000? My brother-in-law just did that for me, and he only charged me $1,600. I said, it doesn't matter. I still have to pull it off and see why the water's leaking out from underneath the head gasket. So he gave me the go, and I proceeded to take it apart. I got the head gasket off, and I look underneath, and the surface of the block's got all these bevels kind of worn off on it from using an air tool. So I give him a price. For a complete new motor, it's $35,000. The yellow goes to the one that's connected to the black on the magnetic switch. The other yellow has its own plug right next to it, comes down to the rotary switch. We're going to cut this one, and we're going to remove this one, and then we'll pull this board out with the magnetic switch and the pot still attached. This black wire right here from the from the rotary switch, goes to that 110 amp magnetic breaker that's no longer being used. So now we have that open for anything we want, because this is coming out with the board. So when we pulled out, disconnected the reverse rotary switch, magnetic switch lost its ground. Grounding through the motor, so we're going to have to rewire the magnetic switch. However, digital plate still works. Here's a wonderful design flaw. Look, the screws are coming from the outside into the motor control board. That means if the motor control board burns out, you got to take off this plate over here. This plate has all kinds of screws. That motor's got to come back out. Those gears got to come off. What a pain. I gotta think about it for a minute. You can see that top. You can see that top screw. One of them is right there, and the other one is 4 inches down, just a little bit to the left of that scratch mark. Damn, that plate is about a ½ an inch thick. What do you think? Maybe we can drill a hole through that plate right there and access that screw. So we started out with a 1/8 drill bit, then a 3/16, no, a 1/4 inch drill bit, then we went up to a ½ inch drill bit. At ½ inch drill bit, we could see the screw inside of the screw. We went up to a 5/8 drill bit, and then we took the die grinder with a small tip and ground out just enough room to get at the screw, and there it is. So anyway, the guy with the Mercedes looks at me shocked, and I said, well, the other machine shop is what destroyed your motor. Why don't you make them pay for it? I'll fill out the paperwork for you. And he looks at me with this dumbfounded look, and he says, it was my wife's brother. If I try to sue my wife's brother, I'm going to get a divorce. And what was I going to say? I just kind of said, okay, well, this is what it's going to take. And he bought it. I'm wondering, one's got to really wonder. Did he tell his wife? He had to tell his wife. Look, there you go. Out. All in one piece. By the way, this board should be perfectly good. I may reinstall that, but if you want this board, contact me. I'll sell it to you. Okay. Some of these wires I put in myself because I had to replace this switch. It was broken when I got the lathe. I matched the color of what they already had. Matter of fact, that's probably their wiring. So the belt box door close switch is a safety switch. It's also red. I'm going to paint these wires white and put them back through there. I don't really like this switch, but you know, someday I might stick my hand in there and somebody else turn the motor on, so could save my fingers, so we'll go ahead and use it. Okay, we painted the wires white for the safety switch right there, and we're going to shove them back in that hole. And we're going to hook them back up to the switch. Notice I just cut them off so I can see the little red tag on it. That way I don't get confused. This yellow wire is now looped from this line circuit, USA positive black wire, AC. to the other pin on the magnetic switch. That wire used to come from the rotary switch, the one with the little knot in it. That's the one it used to come from. It supplies power to the magnet inside the magnetic switch while the motor is running. Should you turn the non-existent reverse switch, it's going to break the magnet and turn the motor off. Interesting, some people think that these machines can switch from forward to reverse on the fly. They cannot. The motor has to stop all the way. What that means is it's pointless to have this switch, because we can do it with the servo motor by pushing the yellow button and achieve the exact same thing. Okay, we're going to screw this switch back down. That's the magnetic release. Okay, so we got the basics in. We're getting ready to put in the main board. We have all the wires that are the neutrals white, and all the wires that are line hot are black now. Same as coming in from this plug. It's plain to see, black, black, and this is positive also. It receives this positive from this line right here. That's to operate the magnet. The ground, or actually the neutral, coming in from here goes through the 16 amp, comes out of the 16 amp, goes through the 10 amp, goes through the emergency off switch, goes through the magnetic switch, goes through the chuck key safety switch. Okay, well, you saw the circuit on the back, so we're only testing the magnetic switch, see if it works. Power's on, power's off, magnetic switch releases. Power's on, power's off, emergency switch. Power's on, power's off. Okay, so that's all working to go to the next step. Okay, we got to bring in the motor somewhere. I guess we'll just bring it in through that hole right there. The plug's too big, so we're going to have to square cut that hole. I think I'm just going to use the die cutter. Maybe you can use a file. It's going to take you a long time, or some other kind of cutting device. Okay, so we cut that hole so the plug will fit through. We plugged in the hole behind it with tape. Run the plug through, and then later we'll address it further. Well, after fighting this, trying to drill it, tap it, and everything else, we just said, you know what, thermal tape would be better. Two-sided thermal tape, much easier. We have alien tape. Not worried about the board overheating. I always stick an extra heat sink if I want to in there. So we'll put the alien tape on, slide it back. Slide it back pretty far, because you're going to need connections here. So we're going to put it as far back, about almost as far back as it'll go. Right about there. And just stick it on. And then we're ready. You can stick the motor plug in already if you want to, just like that. So we cut the display area out of the old control unit box, and we roughed it up, turned it upside down, and glued it right there as a guide to put the display right there. The square is right over the center hole where the reverse switch used to be. That's the best place I can figure to put it, so we'll try it and see what happens. Okay, so the guide's there. We drill 1/8 inch holes where the screws are. Sounding good. 2 holes, then those are going to be backwards though, because of the way they're sitting there. We can eyeball that. That's the top one. There's one up there, and there's 2 on the other side. Little LED lights, indicator lights. All that red's all the rag I put behind there to catch all the pieces. Okay. We also want to etch in this square because we're going to have to cut it out after the fact. Not right off the panel. Clean out the glue. Oh, isn't that hard? Oh man, I don't know. That's pretty hard. Look, it's peeling off the paint. It's okay though. We don't care. We're going to put countersunk screws in here with spacers to hold the panel on the back, so they have the two screw holes have to be beveled to fit the screw so it doesn't push the stitch up. The other light holes need to be beveled too, so the light's going to escape them well. That should be good. Get out the good bits, 3164. One. Two. I don't think we're going to do the middle one. Maybe. Yep, no, it's going to bind too much. Let's try to grind this out a little bit. Bring it in the rest of the way, get the jagged edges off. Just a quality file. You know, the kind that you find in yard sales for $1 that were made in USA because the Chinese ones don't work that good. Okay, so we put bevels in all these little holes. We made these a little extra large, cut this all out, filed it all out. Did an extensive clean job on the inside in particular, painted the outside, made sure we had no metal filings in it, and then we took this board and we glued on the little black 4mm spacers so that this board will sit right across away from the metal, because in the plastic housing it's got the spacers built into the housing. Those 4mm spacers will come with the kit. If you buy the motor, you're on your own. But if you ask me, maybe I'll stick them in the box because they don't cost that much. Okay, we tried several different ways and everything kept falling out. So we came up with this idea. We use really long screws instead of the short ones that came with it and all the short ones I normally use. So we stick this in the spot first. It's easier to stick this in the spot first. And then we put the screws in. Don't push them don't put them all the way in. Leave them sticking up a little bit. And then push them crooked, one way and one the other way. And that makes it stay put. While you hold that, you can get a nut on it. Put one on, I guess. We'll put one on. And then we'll swap it out to the shorter screws. How's that for an idea? Pull out the long screw, put in the shorter screw, still a little long. Now it stays put, at least enough to get the nut on, I hope, without dropping it, I hope. That's one. So this time we're going to spin it up, just almost snug. Okay, and then we'll take out this long screw. And get the shorter screw. You never know. All the work I've done on it, it could be, well, I could have I could have messed it up. Or, you know, it was a new one, so it could be defective right out of the box. Sometimes they are. Okay, so we just put our own speed switch in. This will be available soon. The wire is available now. Notice it's all sealed up. You want to protect this switch from any metal filings, because if you short the wires out, you're going to have big problems. I also sealed up the original tack because it was starting to get some metal on it too. Easy peasy, right? Well, put that in, screw it on. While I'm thinking about it, I was considering putting in a bunch of different functions in this. All you got to do is tap the yellow wire and provide the right resistance. Once the main switch is in, it will fire up, get through diagnostics and everything else. If you tap the yellow wire, provide the right resistance, you can go anywhere from open as dead stop to full speed is about 8K. If you're good at electronics, you can even tap in a CNC control that way. All you got to do is provide the right resistance. Either build yourself a board with a bunch of resistors on it, or provide the resistance. If you build it with the resistors on it, then all you need is on-off triggers on your CNC control unit. That will only give you certain functions. It will not give you, you won't be able to get any feedback from the servo motor, but you can turn it on, turn it off, and turn it on or off at preset speeds. There is actually a way to do reverse, but I haven't broken it down yet. I will eventually. Could put an emergency stop switch right there. What do you think? Is that too big? Well, maybe I should get a small one. Here's a fun little thing to say. I had these fancy double spade connectors I was going to show you, female to male. And you know what? You know you have too much junk when you can't find anything simply because you have everything. Anyway, so we just split the line signal. This goes up to the magnetic switch. That runs the magnetic switch. This runs the, used to run the digital board. Now it's going to run the digital board and the motor. It goes through the 16 amp magnetic breaker. Okay, I know it's going to be hard for you to see all this, but I'm going to explain it to you the best I can. I guess if you're building one, you probably should contact me. What we did is, line comes in under black and white, same as USA from the main power plug, black and white. Goes through the double magnetic circuit breaker, 16 amp, comes out black and white again. Black is, of course, the line signal, or what you might refer to as positive, although with AC it's technically not. Black goes up to the magnetic switch. That's your on-off switch on the front that you're used to with the green and red button. It also, when this switch is on, it bridges positive over to here, down to the old speed board, and down to the new servo motor controller. It also feeds the magnetic switch. Now, I don't know why the Chinese did it in white, but they used the ground side, what you'd call ground. It's neutral. Although if you go between that and ground, you will have continuity. It's somewhere back there, it's joint. Anyway, ground circuit goes through the 16 amp, loops around, goes through the 10 amp, and then it's going to go through the gate switch, the door switch, emergency off switch, and complete the circuit for the positive to return to neutral. What I did here is I just bridged the board into the emergency off switch because it was closest and I needed a ground. Any one of these circuits breaks, you lose ground. So that's going to give me 10 amp protection on the main board, everything actually. I think I'd wire it differently, and when I start building my own I will, but that's what was available on this lathe. Okay, so I'm going to put the back on, and then we're going to do some test it and see if everything works. Okay, last step, let's put the sticker on, and then we'll start trying things out and seeing what happens. Try to get it on there as square as you can. So before I turn this on, when I used to work for Mercedes-Benz dealerships, I'd tear a Mercedes-Benz apart. There'd be about 4,000 parts, and I'm not joking, especially on the dash shop, but that or the motor, the whole thing. And I wouldn't test anything. I'd just put it together, jump in the car, start it up, and drive away. Most people spend hours. I must have did 500 of them, all of them. What do you think? Power on. Oh, it's running backwards. Well, we want to check reverse anyway, so there it is. 3,500, 870. Motor speed, spindle speed. Safety. Now, that's going to blow the magnetic switch open, so you're going to start, switches on, it's in safety, you're going to turn the switch to off before it runs. Works again, stops it. Now, I was going to move this over to here, but I found a better use for that location. Besides, there's a big round hole, and I would have had to drill a round hole somewhere. Right there is where it should be, but you saw the emergency stop switch. Big weird one. Maybe that's the way to go. Also, I was going to put in some different speed controls, but I decided this would be more than I'll ever use. So, running again. Somebody opens the okay. There it goes. Stops again. So, turn it on with the speed switch on. Nothing. Resets off diagnostic. So there you go. You already saw cutting results in the first video. So I'm just going to clean up everything and start making parts tomorrow. I got a few orders I got to fill. And the leg's ready, so we're ready to go. Okay, I put it all back together, and I even cut a bunch of parts because I need to get some parts out. Everything works perfect, but there was a big mistake that well, it's not that big of a mistake. There was a mistake made in the electrical circuits. Did you catch it? I'll show you what it was. Okay, so the black is the line signal. It comes in, goes through the 16 amp, double pole, double throw, magnetic circuit breaker. Black's supposed to go through this 10 amp and through all these circuits. It goes through the 10 amp, which was the mistake, by the way. I left that 10 amp out and I connected this wire to here. So all that's really missing is some circuit protection. But anyway, it goes through first the 16, then the 10, then it goes through the magnetic switch. When you turn the magnetic switch on, it will hold the switch closed. If you break any of the grounds, magnet turns off, magnetic switch goes open. With the switch closed, it goes power to your spindle speed control and to your motor speed control and to any other power consumers. The neutral comes out of both of them. Chuck safety switch, that's the door that opens for the chuck key so you don't throw the chuck key in your face. Belt safety switch so you don't put your fingers in the belt. Any other safety switches can be on this circuit. This will be the white wire, it's the neutral wire. To simplify it for you, call it the ground, but it's not, it's neutral. Goes back through the other 10 amp, back through the 16 amp, and then somewhere eventually out there in your power box, it's going to be probably grounded. It will certainly be grounded somewhere. But neutral is not ground. And if I had a sine wave here, I'd explain that to you. Anyway, so that's all you need to do if you're trying to protect these control boards and you have this kind of system already in your lathe. In reality, all you really need is a double pull, double throw, and you need to rate it for your system. On all of the larger systems, I would just use a double pull, double throw, 10 amp here, and that's it. Wouldn't even use any of these. Optionally, you could just use these. But it's better to break both circuits at the same time than to just break one. I don't know why they didn't build it that way. There must be some kind of reasoning behind it. Anyway, we'll show some more on the next build. We're going to start putting some of this kind of stuff in some of our other systems. Thank you for watching.